I was happy to hear the Dean mention that the concept of building information modeling was invented in 1983 when I got my master's degree. I wasn't aware of that at the time. It took us at Autodesk another 20-ish years to catch up with that thinking. But I'd also say that, at least from my perspective as both a practitioner and an educator, I fall very distinctly in the third category of Alexi's typologies of attitudes. I think that looking at the problem from the perspective of both practice and industry, and then back from education, it seems that the discussion is somewhat more advanced here at the Bartlett, but I'd have to say that speaking for my educational colleagues in the States, the Academy is largely missing from this discussion. The leadership of the conversation is largely led by industry. Industry is creating a context and a series of demands that the Academy is going to have to face up to, because the building industry itself, at least in my view, is largely being restructured by much of these kinds of technologies that we're going to be talking about today. So I want to start by connecting two sets of ideas that I think create a continuum in which we can talk about this. You know, in the Renaissance, Alberti asserted originally that the profession of architecture, the design professions, existed by creating a concept of the separation of the Design Act from the Construction Act. What Alberti said in his famous treatise was that the ideas about a building, a built artifact, operate separately from the ideas about how it is constructed. And at that moment, there was one way to look at that is, at that particular moment in the Renaissance, there was the creation of this idea of information as an overlay to the act of construction. And if we fast forward to the 21st century, and we look at the famous Richards taxonomy, BIM taxonomy, what we see is that elaboration, that sort of original Renaissance idea, has now become a much more nuanced concept, because one of the constructs in the multi-level BIM taxonomy in the Richards ramp here is that the nature of information that is part of the act of building has now become a much more complex, difficult problem. And one of the arguments that I'll make in this discussion is that the design of the strategy of that information, the design of the structure of that information, its use, its interactions, how individuals actually use it, is a design problem much the same as the rest of the problem. So we almost taken this concept from Alberti and made it a meta-design problem. Not only have we created a separation between the concept of a model of design and the execution of that physical artifact, but now the information strategy around that problem has to be designed as well. So let's look a little bit about about the kind of industry context that we're operating in. And I'd like to suggest that, you know, particularly here in the UK, the quality of the conversation is quite sophisticated. This is one of the only marketplaces, and Bartlett produces professionals into an environment where the nature of construction is a matter of government policy. That's actually it's a pretty interesting problem. And the derivation of that interest is government-based policy that suggests that the industry itself has to be refactored in a new way. These are some quotes from the government construction industry that talks about the nature of the industry that we're trying to create and the behavior of the people that we're producing who are going to service that industry about. You'll see here references to ideas of knowledge-based industry, sustainability, economic viability, and the use of information technology tools. These are three kind of large-scale ideas that, as a matter of social policy, are being explored right now in a context of a marketplace that has some really, really interesting challenges. I mean, this 35% number, which is the generally accepted inefficiency factor of the Western construction industry this information comes directly from Egan from the early 1990s. It operates creates a context in which the basic structure of the industry itself is sort of inefficient, creating some interesting sort of economic discontinuities. And the folks that we're educating today are operating in a marketplace where competition is highly globalized, where services are not well differentiated and therefore they're commoditized. That makes for very, very low margins and a different kind of context. Productivity challenges in terms of the efficacy of the movement of information from design to construction and from construction on into building operation is questionable. The attitudes, the sort of unsiloed attitudes that Andy was talking about are going to be necessary to accomplish strategies around sustainability. And then is one of the things I'm concerned about as both an architect and a practitioner is it's just a lot less fun to work in the building industry these days. It's just not as much fun as it was. I have a colleague in the States who's a third-generation builder. His dad came over from Italy. His grandfather came over from Italy as a stonemason, and he now runs a construction company in Massachusetts. And before he discovered the opportunities of technology, he was going to quit because he just said it's no fun anymore. Too many fights, not making enough money, more time spent with lawyers than with architects, and he was looking at, and he was frustrated. And if we want to attract talent into our industry, it not only has to be interesting, it has to be fun. And I think we should talk about that a little bit. Here's one of my favorite quotes from Paul Morrell from a couple of years ago when he was in the States giving a talk. And he talked about this idea that in addition to these other contextual questions, the design problem of the business structures of our industry is to fix these broken business models. That if the fundamental strategy is to break the bargain, the business model bargain on how projects are delivered, we have to attack that problem. And at some level, that's at the essence of what's catalyzing a lot of these kinds of discussions that are going on. Now, one of the ways that I like to describe to my students, actually, Jane, I'm going to move this laptop before I step. I hate to step on Jane's laptop. One of the ways that I try to describe to my students the larger forces that are at play that have to be reconciled in the delivery of a project is to look at this sort of three-part diagram here where you have clients who aspire to execute projects but need help in doing so. You have designers in the lower left-hand corner who create this idea that we call design intent. This is what we want to have happen when this project actually comes together. And finally, there are builders who are responsible for executing that intent. And somehow reconciling those three large forces is the problem of modern project delivery. But the dilemma and the essence of at least in my view, the essence of the problems that are refactoring the marketplace is this inherent tension between design attitudes and construction attitudes, with clients or owners sort of caught in the middle between these two large forces where designers who provide professional services and exercise their judgment and create this thing called the design don't take a lot of responsibility for thinking about how things are built. And this is particularly true in the States. Builders make things, products, they make artifacts. They produce something called the work. And they're not really responsible or very interested in the idea of thinking about design. So we have this interesting red dotted line that creates this barrier condition, and it's a centrifugal force in the systems that create buildings and creates a whole series of tensions and difficult problems of reconciliation. And so what we have to try to contextualize when we start talking about the implications of building information modeling, which if you look at it as an instrument is uninteresting. But if you begin to look at it as a catalyst for refactoring some of these relational problems that we have in the industry, then you have to fall squarely into Alexi's third category there. So one way to look at the problem is to examine how those instruments are used in the process of executing a built project. And the way I like to think about that is that there are four generalized categories of how technology is deployed in the problem of ideation, conceptualization, production, building, execution, and operation. There are representational tools, which are the things you use to collect your ideas. There are analytical tools, which are tools that you use to reason about those ideas that you've represented. There are collaboration tools, which are how you move the information around and get people to work together. And finally, there are what I call realization tools, which are the things that translate ideation to physical artifact. And this taxonomy has been very useful to me to just try to understand where all this stuff is. I mean, Andy mentioned that we're starting to give our software away to students, which is true. You know, our company makes 154 different pieces of software. I can barely keep them straight, and I work there. So I need some buckets, so we use those buckets. Now, if we stipulate that the concept of building information modeling has been around since 1983, then the idea of a desktop modeling tool is a pretty well understood thing. But there are some really interesting things happening now in the realm of big data and other kinds of other technological overlays, and at least in my view, there are 3 of them that are affecting these 4 categories of how we use building information modeling instruments, and those are the cloud, social media, and mobile technology. So if we're really going to interrogate what it means to deploy building information modeling, we have to look at it in those contexts, right? So this is an image from inside of one of Google's data centers, where the kinds of data that Andy was talking about previously are aggregated in thousands of physical machines and tens of thousands of virtual machines, which in the building industry makes for a very interesting proposition, because not only do we have access to the kind of large-scale data that Andy was talking about, but the 2 constraints on the problem that existed in 1983, which are computational cycles and storage capacity, are now unbound in the realm of modeling. And buildings are buildings, build things, roads, highways, buildings, very large, complex, difficult to compute, hard to store. That problem is largely solved right now. Now, when we talk about building information modeling, I think people tend to think of the problem like this, right? Wow, look at that model. Isn't that model, I mean, that thing's finished. There couldn't possibly be a mistake in that model. Someone's worked out every single atom of that building and it's all completely resolved. But in fact, getting to more and more model complexity, at least in my view, is not really the issue. The issue has to do with how information overlays with that model and how we interact with it, and the ability to begin to apply not just large amounts of computation cycles and large amounts of storage, but to begin to overlay logic on top of that model. So there's a second kind of thinking involved in the representation. This particular designer is using an open source tool that we make called Dynamo, which allows the parametric manipulation not of the geometry of a model, but of its building information modeling characteristics. Its structural characteristics, its shape, how it casts shadows. In this particular case, this designer is working on a stadium bowl and is parametrically manipulating lines of sight. But where we have previously used this kind of technology to make cool shapes, or as my other boss, Bob Stern, who's the dean of the School of Architecture at Yale, calls, empower the blobmeisters, parametric algorithms can now be applied directly to the fundamental underlying characteristics of the designed artifact. And that creates a whole different pedagogical problem, I think, for us as teachers. At the same time, that ability to represent a project while it is being designed and receive immediate feedback on the implications of design decisions changes the nature of the design process itself. Speaking as an architect and as a teacher of architects, I think we have very much in the past relied on intuition, rules of thumb, and outsourcing to understand the technical implications of the decisions that we're making. Whereas in the realm of building information modeling, designer can receive almost instantaneous feedback about the implications of her design while it is being developed. This is a conceptual modeling tool that we make that allows a designer to create a building-aware massing model that can report its technical characteristics during the design process itself. And so what you begin to see is the ability to analyze and understand the technical implications of projects very early in their conceptualization. So this particular designer is looking at how the wind blows over the Villa Rotunda, but this is a very, very simple model with a very, very complex technical feedback loop that could be available immediately to that designer as she's developing her scheme. So you can almost imagine a realm in which being able to prioritize and make hierarchical decisions in an analytical context changes the nature of the design problem in a pretty interesting way. Now at the same time, the design of the interactions of the players becomes quite an interesting problem. This is a diagram of there's a whole bunch of software out there now, and you've probably seen some of this stuff, but the diagram of social interactions of organizations. That we have this amazing graph we did of everybody's email address at Autodesk to describe who was talking to who was making, who had how many meeting requests with whom. And you can see from this graph sort of dynamically how people were relating to one another in the company. And so this idea that was part of the design problem of an information-rich building project is to understand what the relational information flows are between the players, and maybe use instrumentation to support that. That's kind of interesting. And then we get to the last question in the question of realization about how design information becomes manifest physically. And so in this particular case, this structural designer has laid out in an architectural form one large piece of concrete that represents her ultimate design intent. And then computationally, we are deriving from that model the construction strategy. So here, we're algorithmically deciding that this is going to be a precast concrete slab. The system is deciding what the slab configurations are. It's figuring out exactly how they're going to be laid out in the field. The shop drawings necessary to generate those slabs are being derived directly from the design intent model. And then it starts to get really interesting because then this designer starts saying, okay, once we've got these precast pieces ready to go, how do we palletize them? How do we lay them out on the factory floor so they're properly produced? And then ultimately, what information do we need to drive the devices that bend the rebar and pour the concrete? So what's interesting about that is, I think that phenomenon is what you're seeing there is a very direct, continuous line of sight between a design intent idea, which in this case was a large piece of concrete, and the manifestation of that piece of concrete in the form of bent rebar in one continuous line. One continuous line of sight. So that kind of construction insight is now available to the designer a priori at the beginning of the process, which I think starts to get very interesting. Now, in the form of social networking, I don't have nearly as cool images as you did, so forget that. We have this question of the next generation of how building industry professionals create insight. You know, as a baby boomer, I'm from the school of hierarchical command and control learning. I'm older than you, therefore I can teach you, I know more than you, and eventually you might know as much as I do. This isn't really the attitude that social networks embody in today's professionals. They aggregate information in lots of new and interesting kinds of ways. I mean, we see, at Autodesk, we see a lot of Revit-related Facebook pages where people are using Facebook to exchange building information. Here, I've got some cool families, do you want to see them? Has anybody heard about this bug? Has anybody heard about this bug? Has anybody heard about this bug? And the kind of spontaneous knowledge structures that emerge that are non-hierarchical and create a different strategy for the way information is actually networked. And one of the implications of that is that the kinds of insights, measurements, the implications of projects start to become apparent in the context of the project as the project is starting to unfold. So although unfortunately the national security apparatus has co-opted the word metadata, I think it's still valid in our context, that the ability to collect social information about the nature of the project, and then deliver it in measurable form as a project is unfolding, is a different kind of analysis and creates a different kind of insight for what happens on a project. Now, at the same time, the definition of hardware, or the definition of how information is delivered to the point of work is starting to change. I think is it going to be next year that more mobile CPUs will be sold than desktop CPUs? Pretty close. That within 2 years, there will be more of these sold than these, which is a pretty big deal. This is a chart that shows the number, in millions of CPUs, the number of different kinds of computers that have been sold over time. And what that means is you can now begin to deliver design information at any particular moment in the continuum. So if you're sitting on the tube and you want to make a conceptual sketch, you can do so on your iPad. The building information modeling version of that layer thing that we were just seeing is this project that we're working on that allows you to take a mobile device, register it geospatially in a three-dimensional area and see the project as it is projected to be constructed, or after it's been constructed as a sort of building information modeling X-ray into the guts of the project, or even be able to, in sketch form on a mobile device, operate in a conceptual sketch that's based on building-aware, geographically registered information at any time. So what you're starting to see is this continuum of digital design strategies from the very beginning of the process, from ideation all the way to the end of the process, where some guy's bending a piece of rebar, all in one big continuous data loop, which I think is a pretty profound concept, and suggests that all that very rich information in whatever form can now be delivered to the point of work of a process and not organized in the traditional hierarchical large drawing size sheet drawing distribution method. If you look at the whole context of what I'm saying, the nature of information about buildings, making built artifacts is going to have to change. And the strategy for how that stuff gets changed, it gets distributed, has to be an explicit part of how we teach people to operate in this context. Now, at the other end of the continuum is this increasingly blurry line, which I think was demonstrated really spectacularly in Andy's talk, between actual physical reality and its digital counterparts. And what we're starting to see is circumstances in which the workflows are composites of design information and scanned information. So this is a laser scan of a large space, and then we're going to take that laser scan of the large space as point clouds and put it into a building information modeling platform. And now suddenly we can begin to manipulate that scan as if we're a building information model. We can cut sections of it, we can rotate it, but where it starts to get really interesting is you can start measuring it, or you can start compositing BIM data with laser scan data simultaneously in the same platform. So if we wanted to make some modifications to this room, instead of having to take 6 young architecture students and have them measure it by hand and make a building information model, we could take a digital camera, take 15 photographs, stitch the photographs together into a virtual laser scan, take that laser scan, put it in a BIM tool, and manipulate the BIM tool live in a composite heterogeneous data stream. So what's interesting about this is not just that we can take a laser scan and stick it into Revit. Who cares? But what is very interesting is the ability to composite design information and reality capture information in the same workflow. And so the barrier condition between physical reality and design reality is becoming really, really blurry. And what you're seeing here are various manipulations of that composited phenomenon, fully measurable, and it can be interacted with as an artifact of the design process. So if we examine the implications of this big idea, these two big ideas that I'm describing, one of which is that the relational structure of the industry is going to be refactored by these bits of information technology that I'm talking about. Then you have to contextualize how we teach building industry professionals, I think, in a different way. And what I want to do is look at sort of 3 categories of this. First is, at a large scale, in terms of the structure of the industry, what are the resulting outcomes? What does that mean in terms of the competencies that we have to accomplish in the folks that we're training to do this? And therefore, what might I recommend would be some pedagogical implications. So, from an outcome perspective, what we're starting to see across Western construction is that the traditional archetypes of project delivery are starting to get examined in different ways. And without getting into the gory detail here, these are the kind of 4 quintessential American project delivery typologies. But what I'd like you to look at in this diagram is the red stuff. The red stuff in each instance represents an opportunity where building information modeling strategies create a different interaction model, create a different exchange of information between players, whether it's the lightweight exchange of model data between designers and builders in a traditional hard bid tender on the upper left, or in the lower right-hand corner, some of these experimental, perfectly transparent, integrated project delivery models. All of this red stuff represents new relations between the various bubbles in these kinds of diagrams, really in the service of what I think is the largest trend that we're talking about here, which is this idea that the siloed attitudes, the siloed deliverables, the siloed strategies that we've traditionally used in the building industry, whether it's the means of representation, the project delivery methodology, or the point of view of the project relative to its sustainability, are being integrated into this technological and sociological idea that everyone is responsible for a whole project. You're no longer just responsible for making the drawings that are discrete to your discipline's responsibility. The structural engineer doesn't just make structural drawings and fling them in a hard landing over the wall to the contractor. That there's now an idea that everyone has to participate in this construct of what is really a whole project. So if you look at some of the later BIM reporting that's happening here in the UK, and I swiped this diagram from Richard Saxon's report from a couple of months ago. Richard's diagram is on the left there that says that the industry is really an intersection of property issues, facility management issues, and construction issues and somehow in the middle of that is this amorphous thing called design and management. I'm going to suggest for purposes of this discussion that our pedagogical obligations are to train a new generation of designers, a new generation of property owners and developers, builders, and facilities managers. And I think I made that little gray bubble in the middle for program managers or project managers. My own view of that is that if we can create a generation of sufficiently competent big bubbles, over the longer term we won't really need the little bubble. Mark, I'm sure you're going to take exception to that. Mark, you sitting in the audience right there. I'll save my views for later. So one of the issues here is the timeline. And I think as educators, we don't talk very much about this, and we really ought to. And there are really interesting analogies between training young building industry professionals, designing buildings, and making software. They all follow roughly the same timeline. If we look, for example, at the career lines of folks that we're educating right now in the window of, say, the next 3 to 4 years, and those folks will come out needing certain very specific skills in the first 5 or 6 years of their careers. Then they will transition from technicians to project leaders by year, if they're really good, by year 8, 9, 10, and then into firm leadership by years 10, 11, 12. Meanwhile, if the technology unfolds as those of us who work on it hope, we're graduating our current group of students into a world of robust level 2 BIM, but by the time they get to the midpoint of their internships, they'll be looking at the early phases of level 3 BIM, and by the time they're actually running projects, if Mark's theory is correct, they'll be operating projects in a fully integrated data context. And then, if my theory is correct, procurement and delivery models will unfold in parallel, and that kind of hard tendered projects will, in the main, and all of their variants, will give way to integrated-like or integrated-ish, what I call pre-integration models that are more heavily collaborative, but maybe this is more of a hope and a prayer than a scientific assertion that by the time this generation of building industry professionals gets into the mature part of their careers, they'll be operating in a delivery context, in a relational context that is radically different from the one that I trained and worked in and the one that most of us work in today. So if that's the case, then one might begin to speculate about the core competencies of these 4 players in these 3 horizons of near-term education, short-term technical competence, and longer-term leadership. And at least in my view, there's a kind of core competency that has to be accomplished for each one of these individual professionals. That the big shift in the attitudes of folks that we train to be property developers and owners has got to be away from commoditized procurement and into this idea that the performance of a building or a built phenomenon is as important as its completion. And that this concept that you would hold a team accountable for how a project performs creates a different relationship to a project than is traditional. That designers have got to begin to define the design problem much more broadly than the creation of a beautiful object or even the creation of an artifact. But there's a meta design problem about how the whole process is going to work that has to be instantiated into how designers are trained. That builders have to not only be sensitized to the question of what design is, but that the execution strategy of how something is built, it becomes part of the discussion of the project from its ideation through its operation. And so that understanding of how a whole project phenomenon operates has to be what we talk about as we train future builders. And then for folks who manage facilities, they may undergo the greatest transformation because they are going to need to really understand how buildings and other built objects behave as opposed to how to just take care of them. You know, instead of having guys with balls of keys on their belts and names on their shirts, we're going to need people with, you know, MBAs to run buildings now. Buildings will be run as strategic assets, not as collections of windows, furnaces, and air distribution systems. So I think there's a parallel set of ideas that can occur and a set of competencies that we have to accomplish in that near term, sort of after graduation, where the developers have to sort of grow up as analysts. The designers have to have a more technical view of the performance of projects and incorporate that into their design strategies. That builders have to be, early builders have to be much more about the planning and the execution of the design than the physical manifestation of it, and that people have to go out and run these complex buildings that we're going to be creating earlier in their careers before they can actually manage them as assets. And then when you get into the later part, and again, as educators, we have to think seriously, what do we want these people to do 10 to 20 years from now? 10 to 20 years from now is when they're going to be operating as mature folks in the industry. What intellectual framework do we have to lay in? And developers are going to have to start thinking about start thinking about themselves as whole project formulators, and architects and engineers as design integrators, and builders as supply chain strategists, and finally facilities managers as strategic asset managers. And I think what I'm suggesting here in this very gentle recommendation as we prepare this next generation for a long-term future of integrated delivery and operation is that there's got to be a much more strategic attitude about the relationship between the pieces, the collaborative nature of the process, and how folks actually work together, catalyzed by the information technology, not because of the information technology. Again, I'm trying to prioritize an attitude over the tools here. The tools are interesting. I think their implications are more interesting. So let me speculate a little bit about what I might recommend in terms of a shift in the thinking in each one of these constructs. So as we're talking about our future property developers and owners, I think that there's a case to be made for reconceptualizing the structure and attitude of how those folks create the process by which built artifacts are made. This is a diagram from my friend Howard Ashcraft, who is he's an attorney in the States, but he's really one of the leading thinkers about integrated delivery in the United States right now. And he makes a very interesting case for how a project should be structured. I won't get into a lot of the details here, except to point out two really interesting characteristics of this basic flowchart that he's created. One is, at the beginning of a project that includes an integrated design, construction, and operation team, is the creation of the business case related to that project. If you don't understand the underlying business case, you're not allowed into the rest of the process. That business case creates a series of measurable objectives that become the baseline by which the project operates for the rest of its life. So the architect does not arrive after the business case has been developed. The architects, the engineers, the builders are part of the creation of the business case in an effort to create a correlated view of how that project works. So that's one thing that's really interesting about this diagram. I won't bore you with the rest of the details except to point out one other interesting thing. In a project, in a future collaborative project structured in this kind of innovative way, there's a part of the project that's all about innovation, and then there's a part of the project where everybody says, we're done innovating, we're going to execute now. No more changing the design. We all agree we understand exactly what we're going to go out and build here. No more elaboration. We've created the information that we need, and when we make the transition from here to here, we're in execution mode. No, we got to stop training these young architects that they can design until the 10 minutes before the certificate of occupancy. And we've got to start training. We've got to start training a bunch of builders to begin understanding how the design unfolded from the beginning, so they can deploy their intellectual assets in the service of that idea. No, whoops, I'm going the wrong way. Now, for designers, I want to suggest two things. So this is a group of my students from a couple weeks ago. They just finished an exercise, a simulation that we run. We ask our colleagues from the business school to run. And it's called the Lego Man. You can see the Lego Man right here. And our first year master's degree candidates in their second semester spend a little bit of time in a housing studio. Then they have a design competition for a single family house. And then they spend the summer building the house. We divide them up into teams, and the stakes are extremely high. You win this competition, your house actually gets built by all of your classmates. But what I realized a couple years ago is we were taking our class, we have about 55 students in our first year, dicing them into teams, asking them to work in teams for the rest of the semester in the highest stakes part of the whole curriculum, and teaching them nothing about how to work together. So we brought some folks over from the business school, and we spent just 3 short weeks teaching collaboration theory. This is how a team works, this is how teams are led, these are how people make different kinds of contributions to teams, and then we run a series of simulations, including this thing called the Lego Man, where there's a guy made out of Legos. You give each team a pile of Legos. You give them 40 minutes to plan out how they're going to build the Legos. And then they have to build an exact duplicate of the Lego Man, and then you time them. Now, what was the big shock for my colleagues from the business schools, they've run this simulation thousands of times at business schools all across the United States, and the MBA students take 7 minutes, 9 minutes, 12 minutes, or often don't finish because they're fighting all the time. They're arguing about how to build a Lego Man, and they just don't finish. The split times for the architecture students are like 1 minute and 12, 90 seconds, because they're spatially really good, and they don't argue like MBA students. But what's interesting about taking them through this exercise is they have to actually think explicitly about how they work together. They have to have a plan for working together, and there's an attitude about collaboration that we've tried to instantiate here. Then the second dimension that I think, at least in the training of architects, is, and I'm going to be as blunt about this as I can. Most of the technology that we use to teach architecture is misapplied in the modern world. We've got a lot of kids out there who can wrangle a copy of Rhino using Grasshopper to make a lot of cool shapes that are deeply meaningless shapes. It's making blobs for no purpose except for beautiful blobs. Don't get me wrong, I teach at what is one of the 2 leading design schools in the United States. Design is a high priority. But if we don't begin deploying those kinds of technologies in the service of how buildings behave instead of what they look like, then someone else in that supply chain, in seeing the market opportunity of the 35% waste factor, will take all that stuff over for us. And at least for the architects, we'll be left with a small number of designers making, SketchUp models, and all the rest of the interesting stuff will be done by somebody else. And I think that's a really terrible outcome. Now, for builders, there are some kind of basic, at least in my view, basic anthropological constructs that have to be destroyed, and then we're going to have to teach different kinds of attitudes for the people who actually build things. I was the client for a project where we did some integrated project delivery experimentation, and this was the most controversial photograph taken during the entire project. On the right is Sarah Vicchese, who is the project architect for my AE firm, my architecture and engineering firm. On the left is a unionized electrician, not the electrical supervisor, but just a guy installing lights on the project. And on our project, because of the project delivery structure, everyone was allowed to talk to everybody else without any limitation All the typical hierarchies were completely destroyed, and if the architect thought it was appropriate to talk to one of the construction workers in the field, even if he was a member of the union and he was an electrician, that was perfectly okay. And so it was a bit shocking. You know, it took a little bit of time for folks to get used to this, but this project was deeply co-located. Everybody talked to everybody else, which sounds like a really stupid thing to point out. Seems like a really obvious thing, but normally it doesn't work that way. Normally, at least where I come from, the way she communicates to him is she goes to the project architect's supervisor who makes a report, who gives it to the contractor's field superintendent, who goes to the electrical subcontractor superintendent, who then reports to the electrical contractor's worker. And there's this big loop, and the 35% number gets higher and higher and higher. So in fact, our contractor on this particular project said that in a normal job, he spends 30% of his time covering his rear end in case he gets sued. That price is built into the price that the client pays for the project. So these kind of change in relational stuff then allows a builder to begin to strategize about how a project is going to be built. This is my project, and these drawings which were derived directly from the single building information model that was created on the project. There wasn't a design model and a build model, it was one model. We're posted in the lifts every day for the builders. So the guys riding up and down in the lifts were seeing diagrams of exactly what was going to happen during construction for that week. And that team, this is a diagram that we used to show how we built part of this project, that team completely conflated the information about the project with the outcomes necessary for the project. So what you're seeing here is the information that was in the model that was used to both design and build the project contained the data that everybody thought was necessary, irrespective of who created it, which is a really interesting idea. So the builder said to us, architects, if you do something as simple as create very detailed information about the partitions in this project, it's a really dumb idea. Very detailed information about the partitions, I can use that information for quantity surveying and to do automated layout in the field. Because we had created a different collaborative construct, the architects said, fine, whatever you need in the model, we will put in that model, doesn't matter. They were literally modeling individual pieces of wallboard. You can see the joint right there. Then when it came time to actually build the layout of this space, that information was extracted directly, used to order the materials, and used to do the layout in the field directly. So it's this idea of selectively lowering the barrier conditions between design and construction in order to strategize more intelligently about a project. And then for our friends facilities managers, I think that there's a need to begin to look at projects as strategic assets instead of as operating machines. This is an analysis that we are working on that looks at the cost in dollars per square foot here of what operations and maintenance costs for a traditional project, and it turns out to be a fairly large sum of money every year. The numbers here are not important. What is important is the idea that a facilities manager can look in a comprehensive way of not just what it costs to run the boiler in the project, but what it costs to actually run the project in total, and use that as a sort of strategic idea, and then begin to take some of the kinds of ideas that Andy was talking about in combination with building information modeling, where you could combine, for example, building sensor information, your business plan for the project itself, and the information that came from your original design model, triangulate those ideas to try to manage the assets strategically. That is a different attitude than how many times do I need to change the boiler, or how many guys do I need to pull a work ticket on a broken sump pump. It's a completely different attitude about how that stuff might work. So I think this conversation about a change in the structural attitude of how we train all these folks is particularly interesting here in the UK, because the government's construction strategy has this concept of what they're calling digitally built Britain, which is a transformation of the construction economy in the information age, not only to attack that 35% productivity idea, but to create a generation of building industry professionals who can lead the world in construction. And this is a dialogue that's, at least in my world, travels, largely missing anyplace else. And what it suggests is there's actually a huge opportunity here. There's a confluence of a bunch of different stuff. And so, just to add in closing, there are a couple different ways to look at this. I think what that means is there are three ideas we have to look at in general that cut across all of these disciplines. One is, this is from a chapter in a book that my colleague Peggy Deemer and I worked on, written by Paul Tombesi, the labor economist in Australia. And he talks about changing the building industry so it operates in the context of what he calls flexible specialization. The redefinition of building design to include a whole realm of activity where participants in the process either operate as controllers or move flexibly amongst all of those different kinds of disciplines. And that's a different idea than this kind of highly siloed structure. The second idea is that information, the integration of information has to be a design problem, it has to be strategized, and everybody on the project has to understand ultimately how that's going to work. And then finally, that there needs to be a collaboration that defines the work of the entire problem broadly, rather than the siloed definitions of each pieces. So in the IPD work that's happening in the States right now, there's a theory that you must design not just the artifact, but the workflows, the team structure, and the communication design. And if we're going to create a generation of folks that can actually do all that stuff, we're going to have to change the attitudes that we use to train them and create a generation of people who understand what everybody is doing collaboratively and can work collectively on a single set of objectives. And I think BIM is one of the underlying ideas that makes that possible.